Hi folks, this is a second tutorial on sprites on the ZX Spectrum Next using NextBASIC. So in lesson 1 I covered how to move sprites about based on key presses, how to get them to stop where you want them to stop, and we used the game Connect 4 as an example. I do recommend you watch that first, as the stuff that I was talking about in that lesson, I'm not going to recover that again now. We're going to rush ahead and do a few new things with sprites. So here we go. First of all, in the sprite editor, I've created a file called pacman.spr. I'd like you to do the same. As you can see, I've created 4 frames of animation here for the Pac-Man character. Mouth open, mouth slightly closed, mouth opening again, and you can see that I can cycle through it like this. So don't think of this as a bank of 64 sprites, although that's exactly what it is, 64. It's really a bank of 64 patterns. You don't have to, this doesn't have to be sprite 0, this doesn't have to be sprite 1, this doesn't have to be sprite 2. It's not like that. You're going to see later that I'm going to be creating sprite 0 and only using sprite 0, but I'm going to associate patterns 0, 1, 2 and 3 with sprite 0. So it isn't like there's a one-to-one relationship between patterns and sprites. The hardware sprites are something separate from what we're doing here. Okay, so hope that makes that a little bit clearer. So save this when you've created these graphics. They don't have to look exactly like mine. In fact, it doesn't even have to be Pac-Man. Just a sprite that you want to animate that has 4 frames. We could do 6 frames, we could do 8, but I've just chosen 4 for this particular example. Okie doke. Right, moving forward then into NextBASIC. And very quickly we are going to load in our file pacman.spr. Whoops. Into memory bank 16, starting at address 0 for a total of 1024 bytes, which is 256 times 4 because we're only using 4 sprite patterns. Okie doke. Let's load the contents of memory bank 16 into the hardware sprites. Now let's clear any on-screen sprites that were there previously, if any, and let's activate sprite printing. Whoops, I got that the wrong way around. Sprite print 1. Okay, now we're ready. And I'm just going to initialize some variables here that I want to use. We'll just use the typical x and y for the position of the sprite. So let x equal 152, let y equal 104. I'm picking those values just because that happens to be the exact center of the screen in relation to where a sprite would be, occupying 16 pixels horizontally and vertically. The actual position 152 is the top left corner of that sprite. With these x and y values. So 152 plus 15 more pixels is the exact center of the screen where the sprite would be. Now I'm going to use the variable z, and I'm going to use that to control the frames of the animation. It's going to cycle through 0, 1, 2 and 3, 0, 1, 2 and 3 over and over again. So we're going to start that at 0. And I'm also going to introduce another variable. We call it d for direction. And I'm going to put something in it initially that will confuse you, but whoops, and I will explain it a little bit later. I'm going to put the binary value 1. So 7 zeros, is that 7 or 8? Whoops. 1, 2, 3, 4, 5, 6, 7. So that's the binary value 1, which is different from the decimal value 1. And that's how we do binary in BASIC. Bin followed by an 8-bit number containing only 1s and 0s. Okay, that's going to control the direction, the visible direction of the sprite. Now notice in the sprite editor we only had the Pac-Man sprite facing right, and you might have wondered, well, where's your graphics for the Pac-Man sprite facing left and up and down. You might have been thinking, well, we don't need 4 frames of animation, we need 16 or 16 graphics. No, you don't, and that's one of the really nice things about how this works, and I'll show you that soon when we come to that. So just bear in mind, we need this here, direction with a 1 at the end. Okay, that's all the variables that I think we're going to need for this. I'm just going to change the color of the screen to make it a bit more like Pac-Man. We'll put a blue border on, and we'll do black background. And although we're not using ink, I'll just set the ink to 7 and clear screen with CLS. Okay, let's just run this and make sure we haven't got any errors so far. Yep, that's good. Now, let's see what we need to do next. Okay, I'll put a rem line in at this point, and we'll call it main loop. And the first thing I want to do in my main loop is display any sprites that I'm using. Okay, so line 1020, the sprite command. So we're going to use sprite 0, that's the only one we're going to use in this lesson. We want it to appear at the coordinates x and y. We want it to have animation frame z, and in the previous lesson the final parameter was either 0 or 1, meaning 0 for the sprite being invisible and 1 for the sprite being visible. This parameter is actually much more complex than just that, and it really expects a binary value. This binary value, right? So for the time being, we're just going to put D in there. So D will be that, and that's the one right there that will make this sprite visible. All right, we're going to do something else with these other values. Let's check that our sprite appears. Good. So far, so good. Okay. Now let's see what we need to do. Okay, let's jump way down to 5,000, and I'm just leaving space here in case I program anything else later. We're going to do movement. So QAOP, typical keys to move a sprite, up, down, left and right. If inky string equals speech marks, whoops, Q, then go sub, I'll put the routine at 7,000, I'll start it with a rem line, and I can just repeat these and modify them just to keep things moving along. Okay, so A for down, and we'll put that at 7,100. O for left, and we'll put that at 7,200. A for down, 7,300. And all I want to do after that is loop back up to 1,000. We can skip the rem line, so 1,010, and that'll keep the computer cycling around waiting for input from the user. Alright, now we need to do these movement routines. So at 7,000, that's move up. At 7,100, we're going to do one for moving down. Okay, so let's do right first, because we've already got our sprite facing the right hand side. So 7310. First thing I want to do is increase the value of x, because that controls the horizontal position of my sprite. So let x equal x plus 1. Now, that's not going to do anything until things cycle back around. So let's just see what that does. Just like that. Because I return, that takes me back up to here, then it goes back to line 1000, which redisplays the sprite and keeps the thing going. So this, I hope, will at least get me moving to the right. Let's check it. I've made a mistake. I'm pressing O. Of course I made a stupid mistake. I did QA O and A. Right. That's not right. Okay. QA O P. I'm trying to go too fast for my own good here. Right. Let's try it again. That's more like it. Okay, it's not doing anything. It's not animated, but at least it's moving when I press the key. So now we want to animate it. So we need another line in here. 7320. Let's do 7. Skip a line for a second. Right. Let Z equal Z plus 1. Okay, because Z controls what frame of animation is happening. And then if we go too far, otherwise it's just going to keep going. Z will go 1, 2, 3, 4, 5, 6, 7, 8. We want to stop at 3 and go back to 0. So if Z has gone beyond 3 to 4, then set it back to 0. Let's set it to 0. Okay, that should animate our sprite. It's really fast. I think the megahertz must be higher than 3.5, so I'm just going to, yeah, it's up at 14. Let's put it down to the standard 3.5 megahertz and see what this looks like. That's pretty good. An animated Pac-man. Right. So now we want to move left. Let's tackle left. Very similar code. 7310, let x equal x minus 1. And we really need the same, a very similar line of code here. Yeah, I'll just repeat it actually. There's no need to reinvent the wheel here. Yeah. Whoops, I made a mistake there, didn't I? I did. That should be plus 1. 7210. Let x equal x minus 1. That's better. So this should move things to the left. I am repeating this line I'm repeating this line exactly, but yeah, you could probably optimize this a bit more by go subbing to that routine, but for now we'll just leave it as is. Okay, let's see if we've got left and right movement. Right, something wrong with my left. What have I done? Let x equal x minus 1. Yeah, we'll go subbing to the right place. Ah, silly me. I forgot to return. 7240 return. There we go. So we've got left and right movement, but we haven't got the turning motion. Okay. So before we do any turning, let's continue and do up and down. Right. So for up, just reproduce this code here. Okay, so up isn't the x variable, it's the y variable. Let y equal y minus 1. And for down, it's y equal y plus 1. Diagonal movement. What have I done? What have I done? I forgot my return again. Right. I'm a little tired. I've been programming all day. You'll have to forgive me. Return. So it was doing multiple routines there. Right, left, up and down. Great stuff. Okay, now we're going to make our sprite turn around. So, to do that, what we want to do, we'll do left first. No, we'll do down first, actually. That's the easiest one to explain. Right. What I want to do here at the end of this line is I want to add another little bit. No, we'll do it on a separate line, right? 7, 1, 2, 0 in the middle, right? So I'm going to change the value of variable d. So originally variable d was set to 1, 2, 3, 4, 5, 6, 7 and a 1. It was set to the binary value 1. So what we're concerned with here are, this is called bit 0, bit 1, bit 2, bit 3, 4, 5, 6 and 7. That's how they're referred to in binary. It's like a units column and then we go further up. Alright, so that's bit 0. We know what bit 0 does already. If it's got a 1 in it, the sprite is visible. If it's got a 0 in it, the sprite is invisible. Bit number 1 right next to it, if it's got a 0 in it, the sprite pattern that you've selected will be displayed as it is. If it's got a 1 in it, the sprite pattern will be rotated right by 90 degrees. Isn't that neat? There we go. Let's test that. So down should correctly rotate my sprite. There you go. Just like that. That one tiny little change. Now if you look, it's staying down. So I've got to do all the other directions. Alright. So if I want to do up now, let's just reproduce that line. 7020. Okay, we're dealing with up. So the next bit along, this bit number 2, when it's 0, nothing happens, but when it's 1, the graphic is flipped horizontally. Sorry, flipped vertically. So I'm going to put a 1 there. So I've already rotated it so it's pointing down. Now I want to flip it vertically so that it's pointing up. Okay. Now let's do left. So that's 7, 2. So I'll return the graphic to normal for this one, like this. And to flip along the horizontal, we want to do this bit here, bit number 3. Put a 1 in bit number 3. So this is rotate 90 degrees. This is flip vertical. This is flip horizontal. Okay? So when it's 0, it does nothing, and when it's 1, it activates it. You'll be familiar with things like this if you've ever done a little bit of machine code assembly language programming. Bits being a whole number being split up into bits in the fashion of flags, as these are typically called. That's familiar to assembly language programmers. Not so familiar to basic programmers, but it's not very complicated. You can, of course, convert that into an actual number. This is the binary number. That's a 1, 2, 4. That's actually the binary number 9. So I could do let d equal 9 and it would have the same result. But you can leave it in binary for clarity. And if you want to learn how to convert binary to decimal and vice versa, it's a bit beyond the scope of this lesson, but you can certainly look up information on how to do that online. It's not too complicated. Now, don't forget the right hand side as well, because I haven't got a statement like this, because if I omit the right hand one, it will never go right again. If I move left, it'll always stay left. It'll never go to the correct graphic for right. So let's put that one in too. And that's just back to normal with the graphic for right. So let's run our code. Look at that. We have a perfectly functioning Pac-Man sprite with 4 frames of animation. And you can stop at any one of the frames like that, and it always remembers the last one. That's really nice. I like that. Okay, so what else can we cover here? There's no interaction with the background. The sprites really sit on top of the Spectrum's native display. in a separate layer, and I can illustrate that by typing list just to show you. You can see that when I scroll, the listing will scroll, but the sprite stays right there. There's no real interactivity between the sprite and the background, but we can force that interactivity, and I'll show you one way that you might want to do that. So the thought I have in my mind is that I want to know not just the X and Y position of the sprite, but I want to know what that position would be as if it were conforming to the old attributes of the old 8x8 color blocks that you would have on the original Spectrum. Because the idea is I could draw the Pac-man maze entirely just using attributes, and I could make my Pac-man sprite stop appropriately when he bangs into walls. As long as I can track the position, that's the main thing. So what I'm going to do here is I'm going to introduce another variable that I'm going to call x1, and then I'm going to do one for y1 as well. So let's go to line 1200 here. Let x1 equal, now if I take x and divide it by 8, that will get me something like the typical XY position that you would use in a print at statement in BASIC. It's not, but it's going to have decimal points in it, obviously. So what I need to do is I need to turn it into an integer. So int brackets x divided by 8. All right. I'll do the same for y. Let's call it y1 equal y, int brackets y divided by 8. Okay, so two new variables, x1 and y1. And just so that we can see what those values are as we're moving our sprite around, I'm going to do a print statement. This wouldn't be in the final game, but for programming purposes this is going to be useful. I'll put it at the bottom of the screen, at the bottom left. X So if you've done a bit of BASIC, which I presume most of you have, you're going to be familiar with what I'm doing right now. Y1. Alright, let's take a look at this. So I've got these coordinates printing. So having divided, x has started off here as, what was my initial value? Let me just consult my notes a second. Yeah, x is 152, but x in terms of a print position in regular BASIC would be 19, which is 152 divided by 8. And as I move around, you can see that it changes, and also the speed of Pac-man is considerably slower now. But it's not going to be accurate. Watch this. So typically when I'm here, I should really be in x position 0. And let's move y to the top. Okay, something has badly gone wrong with y. I've got a 03 here for some 503. Why have I got 03 there? Let me just break out of this a second and run it again. Ah yes, because, yeah, okay. I need to put a couple of spaces after this. Otherwise it won't rub things out for me. There we go, that's better. There we go. So let's move over to the left hand side. Now bear in mind when we're talking about attributes, this is 16 by 16. Attributes are 8 by 8. So I want my x and y values to reflect the top left corner of the sprite. I can't do the middle, I can do the top left corner, but that makes sense because x and y is the top left pixel, so I want the top left corner in terms of 1, 2, 3, 4, the way you would remember attributes being organized. So when I'm here, I want that to be 0, and when I'm at the top I also want that to be 0. So why is it saying 4 and 4? Well, that's obvious, because you can also go outside the screen like this. Okay, so to make that reflect, because in BASIC I can't print outside the border, although I can move sprites outside the border, I can't print. So I want that to be 0 and 0. So all we need to really do is tweak our expression. Okay, let x1 equal integer x divided by 8 minus 4. Take 4 away, and do the same for y. Take 4 away. Now my value should be accurate. Pac-man is running a little slow, so let's bring the megahertz up a little bit to 7. There we go. Yep. 0, 0. Perfect. Now, it's also interesting, just while we're moving the sprite about here, you can see that I can go on and off the screen without doing any harm here. I can actually go a full distance of something like 4 character blocks, and 4 character blocks that way on all 4 directions of the screen. That would be particularly useful for doing the Pac-man routine where he goes out of the maze at the left and appears back in at the right. So that's quite nice. But I want to point out that you don't actually have to have the sprite disappearing behind the border if you don't want to. So I'll just show you that. I can introduce the instruction sprite border 1. I think it defaults to sprite border 0, which means go behind. So let's see what happens now if I use sprite border 1. And it floats on top. That's very handy. And I can go way out to here, and I get an error at that point. So you can get pretty far outside of the Spectrum's native display. So that's good. Okay, so we're now tracking X and Y according to old school attributes. So as a little bit of a test, I'm going to try to make the character collide with something and stop. So I'll do a very quick little routine where I'll draw something on the screen. So let's do just a bar down the center of the screen. So for I equals, say, 5 to 15, print at I, comma, 25, a space, but I want to color it. I want to do it paper 1, blue. And next I. Okay, let's just make sure it's appearing correctly. Okay, there we go. There's a barrier. Now at the moment nothing's going to happen. Pac-man is just going to go right through it. So let's see if I can make him stop, because I know that when he reaches this point, his X attribute is 23. So this attribute is 24. All right. Okay, and you can see that, well, it's 25 actually, I comma 25. So let's see if I can turn on a little bit of collision detection. I will do that down where I'm moving the character to the right. So let's have line, let's see, just going to rename that to 15. So I've got 73103. Now this, the very start, I want to do a check. Check whether the character should move right. So it goes like this. If the attribute located at y1, comma, x1. Now it's a bit confusing because in the past Spectrum always put y before x, but nowadays with the new syntax, it's x first, then y. So it's just one of those things you're going to have to remember. All the old instructions had y first, then x. If the attribute located at those coordinates equals, now I have to specify the color in terms of a decimal number, and it happens to be 15. Here's how you know that. The way attributes are organized originally on the original Spectrum color palette, numbers 0 through to 8 are black paper with all of the different inks, and there are 8 possible inks. Then, no, sorry, I should say 0 through to 7, and then 8 through to 15 is blue, which is the next color up from black, blue paper with all of the different inks. So my display is blue paper, so I know it's going to be in the range 8 to 15 with white ink, and white is the topmost color. Okay, so blue paper black ink would be 8, blue paper blue ink would be 9, blue paper red ink would be 10, and so on. So it's blue paper white ink, which is 15. It is pretty easy to learn if you just look up the table and see how the colors are organized. Then return. So do nothing, in other words, go back up to movement. If that attribute is 15, but that's the wrong attribute, right? That's the attribute which is the top left corner of the sprite. I want to be 2 attributes to the right of that, yeah? Because that's where the wall is. So it's really x1 plus 2. Okay, is it going to work? I hope so. Let's see if I stop at the wall, holding in P, and stop. Great stuff, it's working. So you can see. Can I go around? Let's see. Yes. Now I haven't done anything for left, so I should be able to go left, but if I try to go right again, it'll stop. There you go, some basic collision detection. It's not perfect because it's only measuring the attribute that is 2 to the right of this little, if you imagine the Pac-man is divided into 4 squares, it's only the attribute 2 to the right of that, so it's this attribute here, not that one there, okay? So it's not going to be perfect collision detection. Like if I go down to the bottom like this, it's still working, right? But if I move to the top, I'm likely to be able to float across it here, and I can, you see? Because it's not measuring the attribute that exists to the right on the bottom half of Pac-Man. So you could, of course, do more intricate code. Works okay for a line like that, but it doesn't work in the corners of that line. Yeah. But that shows you how it could be done. That's the very beginnings of how you can do a bit of collision detection and how you can make hardware sprites interact with the existing native Spectrum display. Alright, I think that's pretty much enough for this lesson. Again, have fun with your own coding.